Hello everyone, welcome to our presentation on comparison of machine learning techniques to predict calorie loss from different exercises. My name is Bonifacius Villaoy and this is my partner Jakendra. Before we dive into the details of our paper, I would like to introduce you to the core concept and the main findings of our research. So this research paper examines multiple different machine learning algorithms when predicting the amount of calories that can be lost through different exercise. The results reveal that a combination of linear interpolations and linear extrapolation is, in fact, the most optimal algorithm for predicting calorie loss. This is most likely due to the fact that calorie loss is very linearly dependent on an individual's weight.
And our research starts off with the research introduction itself, and our introduction will cover these three main points. The first one being, weight loss is a major topic for everyone that cares at least a little bit about their health and well-being. And then in order for us to actually achieve this health and well-being, exercise would be the best way to lose weight because it uses calories as energy, which does this the most efficiently. The second one being, most of the time, the average human will stay in the same weight range throughout their lives. Unfortunately, this might not be the same case for some people, and for those people, they will encounter some difficulties. The third one being, according to a survey done by the National Center for Health Statistics, 49.1% of US adults tried to lose weight in the last 12 months, from 2013 until 2016. However, another experiment regarding this consistency in which people exercise in a public gym showed that even though 86.6% of the subjects had memberships to the gym, only 17% of them reported that they were available in all time points, meaning that a lot of these people had memberships, but they did not go to the gym at all, consistently at least, which is why we believe that even if the people who are actually buying something, they don't really do it consistently, which leads us to believe that the person's enjoyment in doing exercise is the best way to counter this inconsistency, which is why we're going to be developing or determining which algorithm will predict the most amount of calories that can be lost efficiently and accurately. Now, here's the literature review where we're going to be comparing other research papers to ours. And here are three main points about this. The first one being variables in calorie loss. The second one is being difference in data sets. The third one being optimality. Now, we're going to look to variables. Now, on this left research paper here, they're focusing on variables that cannot be seen with the naked eye, which is going to be internal body enzymes. And on the second one, on the right side here, they're focusing on things that are more usual, I guess you could say, more common, which is going to be a person's age, a person's weight, a person's height, and so on. And the second point being difference in data. Obviously in machine learning, data and then data bias is a very huge thing in determining the results. And on this left side here, on this left research paper, they found that the best result is going to be having an accuracy of 95.77%. Meanwhile, on this right side here, they use MAE, which is just a counter version of this accuracy, and they found it was going to be 1.48 for the error, which is lower than the left side. But this might be the case of data bias. It might be because the data used on this right side here is more fitting for their models, which may not be the case for other data sets. We don't know. And then on this last point here, optimality. Optimality is quite difficult to assess because we are going to be using an algorithm or algorithms that are not classification based. Meanwhile, on this right side here, they are using a classification based algorithm. So they can use metrics such as precision, recall, and an F1 score. Meanwhile, we cannot. We can only mimic or follow what this research paper on this left side did, which is going to be using accuracy as its main metric.
So, as you know, our study focused on evaluating the several algorithms, including like linear regressions, decision tree regressions, random forest regressions, XGBoost, and also combinations of linear interpolations and extrapolations. The primary objective was to determine which algorithm could most accurately predict calorie loss based on exercise data and individuals' weights. To achieve this, we utilize a dataset from University of Kentucky that consists of data on calorie loss from various types of exercise. The dataset provides a comprehensive view, allowing us to apply and compare different machine learning methods. Also, in terms of tools, we employed scikit-learn for implementing the various machine learning algorithms, pandas for data handling and also manipulation, numpy for numerical computations, and the last one is matplotlib for plotting and visualizing data. And as you can see, we split our data into 75% for training and 25% for testing.
And here's how we are actually going to be using those methods that were mentioned before to get the results. And we're going to be using metrics here to discuss those results. And then we are going to be using three metrics here. We're going to be using MAE, or mean absolute error, consistency, which is going to be covering how consistent an algorithm is in covering or getting good results. And the last one is going to be the error range, because we're going to be using three different executions to figure out if they're consistent or not. And here's the formula for each of them. And here's the actual table of results. Now, there can be seen that the first and second algorithm has way significantly better results than third, fourth, and fifth. And this is mostly because classification-based algorithms does not work well in our dataset. Meanwhile, linear ones do. And this is mostly because the dataset is gonna prove that a person's amount of calorie loss is going to be linearly dependent on that person's weight, which is why these two algorithms will get the similar results and are very accurate in doing so. And the conclusion that we can take here is that linear regression and a combination of linear interpolation with linear extrapolation will provide the most accurate results. However, we are going to be taking the combination of linear interpolation with extrapolation being the most optimal one, because it has just a little bit better error range. It's lower. And then, even though we only use the weight as its only independent variable, it can have a high accuracy percentage, which means it is proven a certain person's amount of calorie loss is very linearly dependent on that person's weight. However, there are some dataset limitations here. The study's dataset lacks diversity in the weight range, so we can't really experiment outside of the known data ranges that are available. The last one being, we only used the person's weight. We did not cover temperature, height, and age, which we do believe that if you cover these three different variables with the person's weight, it would produce better results in predicting. However, with the limited time that we have, we only were able to use the person's weight.
And thank you for your attention and interest in our presentations. We hope you found our research and finding insightful and useful. Have a good day.